All right, thank you. Good afternoon, everyone. Thanks for joining today. I'm Tim Silk, the Solutions Engineering Leader at HashiCorp Federal, and I'm here today with a few of our federal SCs. We wanted to take this opportunity to introduce you to some of the team so you know who to contact if you have any questions. You'll hear a little bit from each of them today. And by the way, you can contact any of them to learn about any of the content you see in here today. They will introduce themselves as they go along, and as well as their areas of responsibility. We're here today to talk about what is really the core of a zero trust architecture, something actually that is often taken for granted, and that is identity. Identity is everything in a zero trust architecture. We trust nothing, authenticate and authorize everything. And that means we need to know who and what are in our environment, on our systems, and what those users, devices, and applications are trying to do. So without establishing a strong mechanism to authenticate and authorize identities, the notion of zero trust quickly falls apart. And with that, I will turn it over to our lead speaker, James Nyika, to kick off the session. James.
Thank you very much, Tim. For everybody who's attending today, the ATalk folks, I'd like to thank you so much for your time and your attention today. My name is James Nyika. I'm a solution engineer with the federal civilian team. So I have for accounts, federal financials. So think of agencies such as the US Treasury and others who handle financial related affairs, as well as Homeland Security, and other security-related organizations with the federal government. So today, I thought I'd start out by just giving a quick executive summary, a bottom line up front that kind of describes kind of what is the idea behind this demo, what were the reasons for why we decided to pursue all of this, and what's really in it for you, right? So when we think about why we came across and decided to put as much effort as we have in this, we wanted to do a couple of things. The first is to really demonstrate for you the fitness for use and fitness for purpose of the HashiCorp stack if you are looking at implementing zero trust principles, architectures, environments within your organization. If you would like to have us share and see some of the more common use cases that we see our prospects and customers asking us to help them to solve challenges around. That's another reason I wanted to share this with you. And we will be sharing back some of these artifacts. They will be available in a couple of different ways. And some of my fellow engineers who will be talking later as well will talk about some of those resources that you can access and where you can access them from. Also, as important as demonstrating is ensuring that we have a way to at least illuminate a path for you yourself to get started and implement these solutions within your own environments, right? And benefits that can be obtained from doing this can be yours as well. And it's important to recognize and to emphasize our enduring partnership with the ATalk organization. This idea of philosophizing and communicating and evangelizing the principles and the benefits that come with zero trust capabilities are also key. So these are the underlying factors for us. And why does this matter, right? So zero trust principles are really going to be and have to be part of the core of the future of secure computing architectures and infrastructures, right? But if they are going to get to that point, it's important that you be able to articulate what those benefits are, and thus justifications for the expense that would be involved in trying to capture those benefits to executive support, to your fellow engineers and peers, to your stakeholders, so that they too can see the benefits that they can obtain from doing that as they migrate to cloud environments, to new forms of compute, and new ways of working within the organization. Zero trust principles, they're supported by automations that improve productivity. Very important is actually this lowering of OpEx cost, right? So we know that Cloud sprawl is a big problem. A lot of technology just keeps going up in price and cost over the years. So, what are some of the ways that this can also help you manage some of that? And then finally, probably one of the most important points is really that overall reduction in risk, particularly security risk, through the reduction and the minimization of that attack surface that we would expose as we carry out all the normal day-to-day processes for achieving the mission, right? And you want to do this the whole time while having visibility, being able to enforce your governance principles and techniques, and having your leadership be able to see and monitor and guide along these activities. So with respect to the use cases, the mapping we had is very much towards thinking about what are the 4 core use cases we wanted to talk about. And the first is really, a lot of it is really standing up that infrastructure. How do you stand up infrastructure securely in a repeatable manner using automation capabilities, right? Because we just can't have things constantly being done manually, because it has the opportunity to introduce mistakes. And then the outcome for that being a development environment, right? That was built really without that risk of credential loss. It's repeatably rebuildable. It enforces policies, and you can also see some cost management capabilities as we do that. The other was really around employees or contractors, both internally and externally. Internally accessing a resource like a database and just having some credentials generated just in time by a secrets management solution. Here we want to emphasize that this idea of credentials that are long-lived can begin to go away, and you can actually have very, very short-lived credentials with fine-grained access to access internal resources. And for externally accessible applications, we're talking about employees that are maybe working remotely from home, outside the headquarters or outside the branch offices. How do you reduce the need for users to remember passwords of multiple systems and really control what they can get access to within that network boundary, and give them access to only what they need in order to perform the work they need to as part of achieving the mission. And then finally, we can't forget also those services and applications, those containers, those APIs. We want to have controls around that too. We want to make sure that if an employer or contractor wants to make a decision to control what is known from one service to the other in the registries, how does one service connect to another service, you want fine-grained control around these kinds of things as well. So these are sort of the broad, high-level business use cases we're going to be tackling today, and we hope these will resonate with you in your environments. So Zero Trust at HashiCorp is really underpinned by what we call our cloud operating model approach, right? So the cloud operating model is really a way of thinking about what that journey from the data center to the cloud looks like. And what HashiCorp has been known for doing for many, many years now is really providing solutions that help you undertake that journey and to avoid the pitfalls that exist along the way. And Zero Trust is an expression of the practices that you would undertake as you go on that journey. So what you see here are really what we call our 4 core use cases that we solve for. We solve for the provisioning function, right? How do I securely provision infrastructure, whether it's in my data center because I'm not yet migrated to the cloud, or in the cloud if I'm already there. Once that infrastructure is in place, it's up, it's running, I've got a heartbeat. The next thing I want to know is, how do I secure it, right? Just like a house that has just had the frame built and the doors put in, how do I put some locks on those doors? Once I have that, you got to remember that if you're in the cloud, for example, that is a network that you're renting. That is infrastructure, compute, storage that you're renting, you don't necessarily control the underlying network. But you still need to have applications running on there that are going to have to communicate and connect with each other in order to perform their function. So the connect piece is handled through one of our solutions called Consul. Consul allows us to basically ensure that that logical network can be laid on top of the underlying physical network of the cloud operator or your data center that helps you manage and control that connection between those services. And then finally, the run layer would be, we handle that with a solution we call Nomad, helps you with the actual deployment process and treating your infrastructure as a fleet of resources, and it makes the decisions for where to deploy your applications. So the only thing from a zero trust perspective that we would say we needed to add to this model was really that of access. How do you have individual employees, contractors, both inside and outside the network, access all those applications, that infrastructure, those secrets, and perform the processes that they need to? And that brings us to our conceptualization at HashiCorp and how we see the zero trust picture. It really starts on the top right with Terraform. Terraform is an automated capability for building infrastructure in the cloud, in the data center, or across multiple clouds at once, using infrastructure as code, which is an approach to building infrastructure where rather than clicking on interfaces and configuring what you want, you simply describe it in a document that allows Terraform to take that and stand up the target infrastructure. So it's much more declarative. You indicate what you want to see and what you want stood up, and that handles it. Where this fits in within the zero trust perspective is it allows you to do it in a way that is secure and does not allow any kind of spillage of secret information, right? So it is mostly automated, takes the human out of the loop, and really allows the tools to do that. But core to this idea is this leveraging of identity, as Tim mentioned, which is a really, really good handle, much better handle than something like IP, which is a little bit more inflexible. It is static and dynamic, but it is rapidly changing in the world of cloud and data centers that need to respond to the demands of users today. So identity as the handle for control is really the basis for our zero trust perspective. And so if you look at the two boxes on the four pillars at the bottom, and on the left, extreme left and extreme right, you have machine authentication and authorization and human authentication and authorization. You have a lot of the tools today for handling single sign-on, which is more of the machine authentication and authorization pillar. You know, this comes in tools like your Active Directory services, your LDAP systems, your Oktas, Duos, Pings, all of these solutions that really manage the human identity fall under that pillar. But on the extreme left, where you have machines that need to have their identity brokered, we provide a solution called Vault. HashiCorp Vault is a secrets management solution, and we'll be talking about it a little bit more. Vault allows you to broker that machine identification, machine authorization, so that the machines can get access to the necessary credentials, secrets that they need in order to perform additional functions. And then in the middle, you have Consul. That is the identity broker that helps you deal with services and applications by name. So again, we see identity coming up to the forefront, really, and kind of superseding IP, right? So we traditionally would use IP as the handle of control. We now use service name and identity as that unit of control as opposed to IP. That isn't to say that IP disappears. We're just saying that from a perspective of handling zero trust control, we work with identity of the service. So what Consul will do there is, using service registry and a bunch of other capabilities, will provide the ability for machines to recognize and connect to other machines or services by name. Okay. And then finally, boundary is the remaining piece that allows human beings to now have a much simpler, better experience, much more secure experience, without any risk, again, of credential spillage for accessing those machines, applications, and services within that network. So these 4 pillars, with Terraform backing all of this with secure, repeatable building of infrastructure, forms that multi-cloud security world of zero trust as we conceive it. So I want to back up, introduce you really to HashiCorp and who we are and what we do. I've mentioned some of our solutions, but we do much more. HashiCorp is a publicly traded company. We're a leader in cloud infrastructure automation. What that means is we really help customers unlock what we call that cloud operating model. That is, that approach, be able to begin to make the transition away from the use of the physical localized data center where it makes sense, and move towards the cloud or cloud-like technologies. And in doing this, we enable that digital transformation of those enterprises. And the way we do this is using our software stack that enables the provisioning of that infrastructure, whether it's in the cloud or in the data center if you must remain there, securing it using something like Vault, ensuring that you can lay down a logical network that allows connecting of applications, services, and virtual machines and containers. And then finally, running your business applications on that secured infrastructure. And all of this hopefully being done with zero trust principles in mind. We do have a whole host of solutions. You see them there on the right. All of them have open source components, and a couple of them, Terraform, Vault, Consul, and Nomad, have enterprise components, with Boundary also having an enterprise component coming soon this year. We're a large company. We've been around for almost a decade. And like I said, we're a publicly traded company with no plans of going anywhere. We have a lot of customers. Some of them you already depend on today for some of the services you consume, whether in private or at the office. Some of them you hope to work for, but all of them have HashiCorp products within their stack, helping protect them through the use of zero trust type principles whenever they have core business needs to protect and ensure that there are no breaches within their organizations. And of these customers, more than 275 of them are in the Global 2000. We have a lot of public sector customers. So if you're in state, local government, or federal civilian, DoD, we have customers in those environments. And 145 of these are Fortune 500 organizations. So again, just hearkening back to that message of this cloud operating model, the reason for that is, securing the data center used to be easy, right? Because it was a well-known physical location. It had a physical boundary, it had a gate, it had a security engineer in there, it had guards posted around the perimeter. And all unauthorized traffic could be restricted and blocked at the door. You had 4 walls, you had a moat. But what has happened is, with the advent of the cloud, that boundary has begun to dissolve. And as it dissolves, and we seek those benefits from going to the cloud, there are consequences, there are implications, right? what happens to your applications and infrastructure as you extend out and push them out to the cloud, to other data centers, or do all of these at once. And it's a challenge. It's a really difficult challenge because you no longer control the network that you own. The machines are not yours. The disks aren't yours. You're renting this infrastructure, but you want some level of control. And what that demands is that you essentially trust nothing, and you have to authenticate and authorize absolutely everything. So we'll talk a little bit about this some more, and you'll see themes of this appearing throughout this presentation and demo. So what have we prepared, right? So we've got a demonstration for you today. I just want to walk a little bit through that solution overview, give you a sense for where some of those pillars we talked about fall into sort of the architecture of this solution. So the first two pillars we sort of will look at is that machine authentication authorization and human authentication authorization piece. And as I had mentioned before, you already have some of this technology deployed internally. We don't seek to change any of it, modify it. We simply seek to adapt to it and use it. So we're talking about your Oktas, Ping, your LDAP servers, Active Directory, whether in the cloud or on-premise, right? These are your identity providers, right, that you use today and we can work with. The second is that layer of machines talking to machines. With the increase in automation that we are seeing, we need to have services talk to other services only when they need to, or on demand, or with credentials that are generated dynamically at that time, right? So we'll talk a little bit about that and what solution we propose there. And then finally, that important, all-important piece of how do you get human beings to talk to those services and applications in a secure manner. So what we'll be doing is showing you two different clients, maybe a DBA and an analyst, or an employee and a contractor who are seeking to access maybe some kind of fingerprint database application. And there's also a data store as part of that picture. How do we use zero trust principles to ensure that these interactions are appropriately done with as little risk for exposing an attack surface? How do we make sure too that from that authentication authorization layer, we can seamlessly connect and allow machines and humans to access those resources? So we will do that through configuring HashiCorp Vault, which we brought into the picture as well, to really act as an identity broker for machine-to-machine access, right? What that means is it will act as the verifier with the IDPs, the identity providers, of the machine identification, whether through certificates or tokens, however it is we configure it, and acting as the broker for the secrets that are needed for those APIs and machines to get access to all the different resources that are out there. On the human authentication authorization side, we're going to see how we can have Vault be the identity broker for doing things like rotating credentials where necessary, or ensuring that a user that wishes to access this can be, all that can be brokered through the Vault. And then finally, for the machine-to-machine access, this is where we'll see how we can use something like Consul to, first of all, configure and set up a service registry that can be used for service discovery. How we can set up a service network and ensure that network has mutual TLS for all services that are trying to talk to each other and referring to each other by name. They're all using IP underneath, but abstracted away is all of that, and you really just need to work with service names. All right. Boundary would be the last piece here that would be the client that allows you to connect securely and talk to that fingerprint application and database. This is a fantastic new capability we have on offer, and one of my peers will be showing you how we can get that to happen. All right, I would like at this point to allow Dan Fedick to introduce himself, and he will be talking a little bit about some of the Terraform pieces and what we will be doing in the coming slides. Thank you. Dan?
Thanks, James. Well, my name's Dan Fedick. I am a solutions engineer here at HashiCorp. I work mostly in the federal civilian sector. And today I want to talk to you a little bit about Terraform. And Terraform is our infrastructure as code tool that allows us to basically create resources that we declaratively define the resources through, say, attributes for each resources, the same way we would do so through a console or a UI, but through a codified version, so a configuration file of some sort. The nice part about doing that through a configuration file is that we can use common development workflows like your version control systems like GitHub or GitLab. And we can actually, create merge or pull requests and see who's making changes to the environment, why they're making those changes, and when they're making those changes. Another thing that we can access is that CI/CD pipeline. What integration tests, the I in integrate in CI/CD is integration. So what tests can we run against your environment before they go through that staged approach of development to staging to production? We can run tests that say, I want to have tags on all of my resources that look like X, or I want to make sure that if I deploy S3 buckets, that they're not public, that they're privately, I want to make sure that my instances are, specific sizes so that we don't overrun our budget, or any other, say CIST policies that that come down through your organization. You can codify those through our policy as code tool called Sentinel, which is a part of Terraform. And when you deploy your infrastructure, those Sentinel tests can be run against your infrastructure to ensure that it's not a deploy your infrastructure, then test it. It's test before you deploy, right? So everything within your environment is then tested. Another thing that's nice is RBAC. So we actually are a team of, a few people that help build this out. But as your organization grows, you'll have, say, a security team and a network team and a services team and an instance team or something that help build all this different infrastructure with different roles. But with Terraform, we can have access to specific workspaces or to specific infrastructure to build that infrastructure out based on the actual role that you need at that time, right? Every event that happens within the organization, within Terraform, it can be sent off to an event management system like Datadog or Splunk, or just a syslog for that matter. And also that whole concept of like having a history book, using your version control of like everything that's happened throughout your environment. So you can in real time monitor using your event management systems, or you can go back in history with your version control to see everything that's happened, when they happened, and why. As we're building the infrastructure out, you start to see common patterns that reveal themselves, right? So if I build an AWS VPC out, I want to make sure I do so the same way every single time. In this case, we use a public VPC module. We call them modules, these patterns. We build in modules, and then we use those modules by passing attributes into those modules. We can use public modules, or we can use private modules that we create as an organization. And then we can store those in a private registry through Terraform Enterprise. And as an organization, we can say, this is the way we're going to deploy infrastructure from now on, right? We always use these tags. We always, build infrastructure this way. And as organizations grow, it's possible that you're moving from on-premise into, Amazon Cloud, or into Azure, or to GCP, or even in Oracle. We have over 1,000 providers. A provider is basically a Terraform integration that allows us to work with all these different cloud providers and be able to have the same workflow across all of these different environments to create the zero trust model. So what you see here is the infrastructure that we built. I'll go over a little bit later on all of the infrastructure we built and how we built it using the Terraform product, but that's just an introduction to Terraform and how we provisioned that zero trust model. We'll go back to James real quick and let him tell us a little bit about Vault.
Thanks so much, Dan. I wanted to also introduce Vault, which is our secrets management solution that we use to secure a lot of the machine-to-machine components and that authentication authorization portion. So what Vault does is Vault leverages sources of identity and brokers that identity request and redirection, and allows you to do a couple of things. It first of all allows you to store secrets. What is a secret? A secret could be an IP or an API endpoint. It could be information like your credentials, your username, password, maybe some special token that you have, a private key, an SSH key. It could be a TLS certificate or the private key portion of a TLS certificate that you want to use. It could be ciphertext. It could be even some snippet of a log file that you want to keep secure, or it might even be a policy document or description of some kind. And so what Vault does is that it stores all of this securely behind a cryptographic barrier, right? While giving you a choice for what storages you want all of this to go into. So you could have different backends for the Vault that allow you to store, say, encrypted secrets in a database, on the file system, in a bucket, in the cloud. There's a number of different options there. So you can store secrets. You can have Vault dynamically generate secrets for you, right? So this could be database credentials. This might be tokens. This could be certificates, right? Or it could even be one-time passwords for multi-factor authentication, MFA. Vault can also encrypt or decrypt your data for you. So that's the second use case that you see there that allows you to keep application data secure across various environments. So if you wanted, for example, to work with Vault in FIPS mode and you have an HSM, you could do that. Vault also is a broker for identity, and it can also manage keys for other systems. So for example, we can manage master keys for SQL Server that's doing transparent data encryption. So storage arrays such as NetApp, if you wanted the master keys for storing data at rest to be managed through Vault, that Vault can do that as well. So Vault is an extremely flexible capability delivered to you as a single binary with both with a UI, with an API, a REST-based API that's accessible to you, or a command line interface. So it gives you a whole range of ways in which you can interact with it, but gives you all the goodness and all the business benefits of ensuring it secures your secrets within the organization while making them flexibly reachable for any man, woman, machine, API that has the appropriate credentials to access them. So at this point, I wanted to move on and ask my colleague Greg to introduce himself and tell us a little bit about Consul.
Hi, I'm Greg, and I support DoD and IC here at HashiCorp as Senior Solutions Engineer. And James, thank you for explaining what Consul does. Today, I'm going to tell you really a good way to think about Consul and what it can do for you. Think about Consul like a brain. So first of all, with service discovery and health monitoring, it's like a librarian. So it's taking the dynamic services that you have that need machine-to-machine access, and it's allowing you to check the health of both legacy and ephemeral services. And then it provides multi-platform service networking. And what does that mean? It can connect everything inside of Kubernetes clusters. Today, we're going to give you a demo in ECS, but it could be something back on-prem. So it's allowing you to connect anything in a multi-cloud platform using MTLS. So anything that's not cryptographically proven won't be accepted. And then what Consul is not, is it's not a replacement for your traditional networking tools like Cisco, F5, and Palo Alto. But what it does is it helps you deliver applications faster with network infrastructure automation. And I'm excited to get into the demo, and I'm going to go ahead and pass it to my colleague, Luke. Thanks.
Thank you, Greg. My name is Luke McCleary. I'm a solutions engineer here at HashiCorp as well, covering federal. Today, I'm going to be talking about our Boundary product. And Boundary is our solution to address granular human to machine access in a highly distributed dynamic environment. And really, it answers the question, what does system access look like in a world without VPNs? And before we get kind of into, we can advance here. I'm not going to spend too much time on this one. Before we get into exactly what Boundary does and how it does it, I want to spend a moment to kind of address what the traditional access workflow looks like in environments today, so we can kind of compare and contrast how we've made improvements with the Boundary solution. So, in the traditional access model, what most people are looking at is a VPN-based solution, right? So VPN's been around for 40 plus years. It's the tried and true technology for accessing a solution that's not where you're at, but it has challenges. It wasn't built for a dynamic world. It wasn't built for the world we live in today. It was built for the world of yesteryear. And as a result, it's built with this kind of castle and moat perimeter-based security in mind. So, when you log in with a VPN, once you're inside the network, VPNs traditionally give you very broad access. You can access everything within, at the very least, a network segment, if not more. And while we can introduce some additional security controls on top of this, things like access control lists, aka ACLs, what you'll see is that ACLs ultimately are really operationally costly and complex, and they depend heavily on static IP addresses to maintain their rules and structure. On top of this, you've got, of course, VPN hardware costs, VPN licensing costs, all the configuration to manage, split tunnel, captive tunnel. How do you deal with DNS? How do you deal with multiple sites? How many different VPNs do you have to log into to get access to your resources? So you bring all this stuff together, and VPNs really just aren't the solution for the future data center, or the dynamic world. But beyond that, there are additional challenges with the access model. So VPNs are one piece of it, but another piece of it is really just keeping track of your resources. How do you manage a catalog of thousands of different assets across multiple clouds when their IP addresses are constantly changing? It's not very easy to track these resources because they don't stay the same. Every time you every time you restart an EC2 instance, you get a new IP address. Every time you expand an elastic group, you get a bunch of new members. And we need a better way of tracking these things. And then finally, there's the credentials challenge. VPNs only get you so far. They can get you connected to a particular resource, but it doesn't get you logged into that resource. It just gets you at the front door, so to speak. And the problem with the credentials piece is, you have to figure out, in a world where you have thousands of resources, what are the credentials I need for this particular box? Do I look them up in a spreadsheet? Do I know them? Are they part of my existing login workflow? Generally, the questions you ask yourself when you get to this point in the login process are, where are my credentials? How old are they? How broad is the access for these credentials? And are these credentials being reused elsewhere? These are all security challenges. And the answers to these questions are usually, the answers are they're long-lived credentials. They've been around for a while. They probably have pretty broad access, maybe admin level, not uncommon. And most kind of scarily, they're probably reused across other systems. And we need to kind of stop this behavior if we're going to increase our security posture in the modern world. And a final note here, VPNs, as we all know, are a very common vector for breaches. Something like 60 or 70% of breaches happen because of some kind of a VPN credential leak. And if we can provide a way to further lock down the way we access our resources, we can reduce that attack surface. So what Boundary is doing for us is, of course, solving all the challenges we saw on the previous slide. Otherwise, we wouldn't have brought them up. But what you see from a user workflow is, you come into the system through a modern authentication system, something like Okta, Microsoft Authentication, Amazon, Google. We use the providers that are available to you at your fingertips already. So onboarding and offboarding is super simple. You just use the existing OIDC-based technologies you have in your environment today. Then we grant access to resources, aka your hosts and services within your environment, based off of group membership in those OIDC providers. So you log in, then you have a catalog of resources that you can choose from to log into. And this catalog can be generated dynamically, it can be generated statically, it can be generated programmatically. But really the most powerful piece of this is the dynamic piece, where workloads are coming online and offline all the time in our environment. And we need something that's a kind of a living organism to track and maintain a list, a catalog of these resources as they live and die in our environment. And we're able to do this through native tagging. So you basically create tags within AWS and Azure and Consul, and the product's able to pick those tags up and place them in the correct host groupings for your users to be able to connect to them. But of course, we do still support the legacy static infrastructure approach. So we've got you covered in the old world and the new. And finally, there's the credential piece of this. We want to make it really simple for people to just connect to the resources, but we also want it to be secure. And to do this, we integrated with our Vault product to provide these on-demand, least privileged credentials as part of our login workflow. And we'll see in the demo, we're basically generating a credential just for this one session, and it will expire within 5 or 10 minutes after that credential has been used. So you don't need to worry about potential leakage of a credential, or for that credential to be over broadly and too broad access to be defined within that role. So with that said, we'll just kind of walk through a day in the life of a Boundary user. They come in through the interface. We have a client that they log into, supports Windows, Linux, and all the flavors that you would expect. They authenticate with a provider of their choice. We support as many providers as you'd like to configure. We can do multiple, we can do a single provider. But once they're logged in, they get authorized for the resources that they want to use. And then they simply log into that resource and are provided a credential by our integration with our Vault product. So they don't need to go searching for a credential. They don't need to worry about it being reused or potentially being stolen and used maliciously in the future.
All right. Thank you, Luke. So at this point, we're going to be jumping into the demo portion of this presentation. Just for the sake of all the attendees, I wanted to make sure I brought up the solution overview again. This is sort of the framework around this particular demo that we'll be showing you. You'll see some of the boundary pieces in action. We'll talk about Vault. I'll show you some of the Vault interface. We'll have Dan talk a little bit about the underlying Terraform pieces that actually built all of this infrastructure. And last but not least, Greg will also talk about how machine-to-machine access can be achieved within this particular environment. So I'm going to stop sharing here, and I'm going to ask Dan to perhaps take control of the screen and show us the Terraform pieces.
Awesome, thanks, James. Well, first I want to go back to this diagram that I had up earlier. This is the infrastructure that we built to build our application out, right? So we have a mock fingerprint data application that connects to a database. But in order to build that, we had to have an AWS VPC. And in that VPC, we had to have multiple availability zones. We had to have multiple subnets, a private and a public subnet, route tables. And once we had the VPC built, we had to then go build our ECS cluster. And ECS, if you don't know what it is basically a microservices runtime or a container runtime. In this case, we could have used Kubernetes or Nomad, any other microservice or Docker Swarm. But in this case, we use ECS container system to deploy our Vault server, to deploy our Consul server, to deploy our fingerprint application, that has sidecars for a proxy, and then for our Consul client connect, which is basically our connects layer of our machine-to-machine access, right? So then and Vault is that secure layer, so doing the brokerage of the machine-to-machine authentication at the TLS layer in this case. Then we built our, to access this, we built our auto-scaling groups for not only for the ECS cluster, but also for the boundary workers that are in the public subnet, the boundary controllers that are out in the public subnet, and then the application load balancer that sits in front of those. And then also, obviously, at the bottom, we have our AWS KMS system, our ancillary AWS services, and our Postgres database, right? So that's the infrastructure that we built out. Well, I talked earlier about building infrastructure as code, right? So we can build that infrastructure as code, but we want to be able to still see things through a single pane of glass. Writing code is nice because we can make common patterns, but it is still nice to have a UI. So in this case, we store all of our state in Terraform. And can you guys still hear me? I just saw a connection. Anyway, so this is our Terraform cloud. Terraform cloud is hierarchical in nature. So we have an organization, which is basically a conglomeration of a workspace, and a team. Basically, each team has access to specific workspaces within that organization. So in this case, say I was in the network team, for example, I would have access to one workspace, and that workspace might look like the AWS VPC. In order for us to build this workspace out, we would have a repository, a VCS repository, or version control system. In this case, we're using GitHub, and you can click on here to see the actual code that we use to build this infrastructure out, right? So here's this module right here is the actual kind of the core of the infrastructure or the core of the code that we use to build out the infrastructure. So this is the VPC module, which is a resource that we apply attributes to. And those attributes in this case are the name for the module, the private public subnet IP addresses, the things that you'd need to build out a VPC through the console, but we're doing it all through this one, through code, so that we have a repeatable manner to do things in, right? So once we were to merge this into this repository, a run would happen. So a run is basically a plan and an apply. I just recently ran a plan. A plan is basically a differentiation between the state in which Terraform understands the infrastructure and the state in which we're telling it we want it to move to, right? So the from and to. So we could be deleting, modifying, or creating brand new infrastructure in this state. And you can see here that when we built this infrastructure, it came with 21 resources. So those 20 lines of code built out 21 resources in our AWS console. And then out of that, we applied some output variables so that we could use them throughout the organization. And we could pass those to other workspaces within the organization. Say somebody wants to pass in a variable that's the AWS VPN gateway or the VPC ID, right? So we could use those outputs here, or we could not allow anybody to use those outputs if we wanted to. And we talked a little bit about human-to-machine and machine-to-machine authentication. Really, there's three big pillars: there's human-to-machine, machine-to-machine, but then there's also some of the event management aspect of Terraform that we want to make sure that we have in our environment, right? We want to, so human-to-machine, we have things like teams. Now, a team we can just set up a team that just has access to these workspaces that are all of the authentication happens within Terraform, or we can use an SSO provider to use as our main authentication and authorization aspect. So we can say Microsoft Azure AD, Okta, SAML to connect into and drop us into a team that has assigned a role. In this case, we're on the owner's team, but we could have plenty of teams if we had developers or database admins, or we can create whatever team we want that has access to specific workspaces. And then from the machine-to-machine aspect, each workspace, so each user has access to a workspace, and each workspace has access to specific resources within AWS or within Azure or with whatever cloud providers that we're using here. In this case, we're using AWS, and we're using AWS Access Key ID and secret tokens. Now, obviously, this isn't always the way you'd want to do it. You can actually create Terraform runners, and that service can have very specific role assigned to it. And so you don't actually have to pass in access key IDs. I know that's a big question, but we can have runners that run with a specific service role versus using access key IDs. But this access key would then have access to only the VPC network resources. That's your machine-to-machine access, right? And then when we push code to to GitHub, a plan would be run. The last time I ran a plan, I made a change where I was going to delete a tagline. The do not delete is equal to true line. So the reason why we do that is because at the end of this, I'll hit apply, and all my infrastructure all the tags will be removed. The do not delete is equal to true. We have a little Reaper that comes in and removes any infrastructure that doesn't have the do not delete equals true tag. So that's just for later. I'll hit an apply on this, and all this infrastructure will be torn down, and there's no cloud waste and cloud, that's sitting out there that we forgot about because we were tired at the end of this, right? Another thing that happens after you run an apply is that you actually get a cost estimation. So say I'm going in to start a new project. I write up the code to build out the infrastructure for this new project. How much is that going to cost? I don't know. It's going to cost maybe this amount of money. Well, based on the cost estimations, we should be able to say to our budget, the person managing the budget, this is going to cost us $100 a month. Well, this is the VPC resource, and this is $0 because all the ticket items in this are $0 items. So, so that's the one more thing I wanted to show you is that this acts as a history book, right? So like every run that's made in your infrastructure, every change that's made in your infrastructure is tied exactly to that commit hash, who did it and why they did it. So I can go and say this was run using this code, and I can click on this and see the actual commit hash. These are the lines of code I changed in my provider. And this is the things that I did that made the change that broke the problem, or that gave us the problem in the first place. So you can, and guess who did it? Me, right? So you can do a git blame on it and say this person made that change, right? So you can go back to the source. So we went over the machine-to-machine access, the human-to-machine access here for Terraform, and how we went about as a team to provision all this infrastructure, and then how this acts as a history book to create events that we can go back to. And then also, Terraform, every single infrastructure change that we make creates an event that can be passed off to an event management system. I'm going to give it back to James so he can go over and show us a little bit about how Vault helps us secure our infrastructure.
Hey, thank you very much, Dan. I'm going to share my screen back. And if everybody can see my screen, what you're looking at now is the Vault portion. So this is the Vault user interface. So one of the things I had mentioned earlier is that Vault is delivered to you actually as a single binary, couple of different packaging formats. You can get it as an RPM package. You can get it as a container. You can get it as a binary for your particular operating system. There's a number of different ways we deliver it to you. In this particular case, it was actually configured and stood up as part of that Terraform run that Dan just talked about. So not only does Terraform help you build compute, storage, networking, but you can also use Terraform to configure applications. So there are more than 1,000 providers out there, many of them for third-party applications, and being able to configure various aspects of those applications. So what I'll be talking about here is showing you one of those configurations that was performed as part of the runs that Dan and my colleague Luke had performed. But in this interface, I just wanted to give you a sense for what capability does Vault kind of expose directly through the user interface, right? Remember, you can also access all of this through the CLI, a command line interface, or you can use an API. If you know how to use curl or any of the REST-based clients, you can also use those. So in this particular view, you can see it's about secrets engines. A secret engine is nothing but a module for integrating with a particular type of either cloud provider or credential generator. So we have key value stores, which is just a classic, cubbyhole to put in 2 values. You can generate PKI certs, SSH keys. If you want to dynamically generate credentials from all these cloud providers, that's open to you. Here are a few of the other applications that you can connect to and configure and actually generate credentials for as well. And you notice that we have compatibility with our own solutions as well. Today, I will be focusing on this particular one around databases because we have what we call a dynamic database secrets example, which will be here. And I'll go into that in a second. Quickly show you some of the other access menus. Vault is a broker for identity, as we talked about before. How do you do that? Well, we do it by allowing Vault to accept and configure many different ways to authenticate. So here are just a couple of those, including OIDC. You can authenticate using a TLS cert, username password, which we all classically know. You can use your cloud credentials to log into Vault, or your GitHub credentials, or your Kubernetes credentials, or any generic OpenLDAP or Azure AD credentials to log in, Okta, Radius servers. And this is just a small part of the list. And if you do not see an authentication method here that you use today, we can help you build and develop an authentication method for your particular organization. Everything in Vault is controlled through policies. My colleague Luke will talk a little bit more about that. And of course, being a tool that's so heavy on encryption, we give you a bunch of basic tools that you'd expect: ability to wrap data, unwrap data, being able to generate random bytes or even hash information. You can do that as well. So coming back to this particular piece where we used Terraform to actually talk to the Vault server and configure it. What did we configure? Well, one of the things we configured was some connection information to a Postgres database, right? That includes the user and credentials to log into it, number of connections. All of this was not done by a human being. This was done through Terraform. And then from there, we can now define what are called roles, which are specific configurations for generating credentials based on the role of the person that would like to deliver the credentials to. If it's a DBA, those credentials might be longer lived, right? If it's an analyst, they might be much shorter lived and much more restricted in scope in what data they may be able to access. And this is possible for Postgres, for Oracle, for your MongoDB, your Cassandras, your MariaDBs, MySQLs, SQL servers, doesn't really matter, right? And so what is key here now is in this interface, if I had access to it, say as an operator who manages this, I can pick the particular role for which I'd like to generate credentials. And actually, it's as simple as saying, generate some dynamic credentials. You can see the least duration for these is 5 minutes. And right there, you can see the information that is generated for me. So these credentials will be cleaned up and will be useless within 5 minutes. This is just a short example of how you can use Vault for some of those zero trust principles, such as just-in-time credentials, short-lived credentials, right? To access resources and controlling exactly how far in those resources you can go. My colleague Luke will talk a little bit more broadly about another way to do exactly the same thing. So at this point, I want to stop my portion. I'd like to pass it on in this particular instance to Luke. Let me have Luke talk a little bit more about how Boundary would expose some of this.
Perfect. Thank you, James. All right. So before we jump back to, yes, okay. Sorry, before we jump back into my demo, I wanted to give you a quick overview of the architecture of Boundary and how connections work. So there are really three components when it comes to our Boundary solution. You have the client, which is run on a desktop somewhere typically by a user, a human operator. You have the boundary controllers, and this is where your catalog lives. This is where you set up all the configuration for your boundary infrastructure. It's a highly available cluster in most configurations. And then finally, you have these workers, and these workers live on the edge of your network, and they act as proxies for connections to resources wherever those resources may live. So you deploy these workers on the edge of whatever network segments you have throughout your infrastructure. And the way it works is when you look up a particular resource within the boundary cluster of controllers, it will send back the connection information to the user as to how and where to connect to a worker, and then ultimately the workload that they've selected. So we'll kind of show you how that works now as we log into Boundary itself. So let's go ahead and log into the Boundary controller. It's all an HTML5 interface, and you can see here at the UI for our Boundary controller, we have a few options when we log in. We are a full multi-tenant role-based administration product. That means that you can choose to log in at various levels within the multi-tenant structure of the product. And you may only have access to a particular organization, so that would be necessary for you to select the scope that you want to log into. At each one of these levels of the organization, you can configure authentication methods. For this demo, I've integrated our OIDC functionality with Auth0, which is an Okta company, just to demonstrate how we can log in through an OIDC provider. But you can also log in with a username and password if that's your preference. But if I go ahead and hit login, it'll redirect me to my OIDC provider. I'll jump in my credentials for my provider. If I have challenge set up for time-based passwords, it would challenge me. I didn't set that up for this particular use case, but once we're authenticated, it'll drop me into the scope that I requested to be logged into. And as you'd expect from a multi-tenant product, each organization has its own users, its own groups, its own roles that you can define for building that role-based administrative structure within your organization. We can also define additional authentication methods. You could theoretically have, in a single organization, logins for Okta, OIDC, Amazon, Google, Azure, and we can act as a broker. We can even use Vault as an intermediate broker and actually have Vault act as our OIDC provider in some use cases where it makes sense to kind of aggregate multiple OIDC providers. The next piece we'll talk about here is a scope of our multi-tenant structure called a project. And a project, this project called DB infrastructure, is where all of the configuration for our secrets, our hosts, and our target and sessions live. This is where we actually build out, all of our configuration information for our infrastructure. We can configure credential stores, integrations with Vault, which we'll show you how those work later. But this is basically where we keep our passwords for our workloads. We can configure our host catalogs here. We can configure them either in a static fashion or a dynamic fashion. Static being, we're just kind of manually adding in IPs for resources that are, aren't going to change very often. Or more powerfully, we can use dynamic host catalogs that will automatically pick up resources out of Consul, Azure, AWS, etc. And that's where the power of Boundary really shows its strength. And once we have credentials and a host catalog, we can start creating targets. And targets are basically a port, a credential, and a host for us to connect to. And we've got 3 examples here in this particular project, and we'll show you how to connect to these things over on the client side of the Boundary equation. So let's jump over there now. So as you can see, I'm running OS X. I have a Boundary client installed here. It's already open, and as an initial step, I need to authenticate. And once again, we're presented with our multi-tenant structure. We choose which org and method we want to log in with. I choose OIDC. Once again, it's going to challenge me for my credentials, and then we can proceed to log into the Boundary client itself. So now we're authenticated, and as you can see, the boundary client looks a lot like the project screen that we were just on. The only difference being, the only thing we see here are sessions and targets, and we can choose, an organization scope if we want within the UI here. This makes it very simple for our end users to log into resources that they own. By defining policies and creating multiple projects for different use cases, we can create basically a role-based administrative product where we have power users, administrators, DBAs, analysts, and they all have different levels of access to either the same systems or different systems. And I've kind of aggregated that into a single example here where the roles that we defined over in Vault actually exist here within Boundary. So that same P-SQL database that James gave us a demo of earlier is fully integrated as a connection item within the Boundary product. So I can choose to log in and establish a connection as either a DBA or as an analyst. In the real world, you'd probably have these split up and issued to different users, but we'd want to easily demonstrate the capabilities here. We also have a Vault SSH target here. Remember, a target is a port and a host. So when we make a connection here, we are making a connection to an individual port on a host. So the first thing I want to demo for you guys is just a simple SSH session tunneling to a Linux machine living in AWS via the worker that has been defined within our infrastructure here. So to do that, I'll hit this connect button and it will establish this session. And this session is going to be established on kind of a random port locally on my machine. And what I can do is I can take that random port and forgive the history here. There we go. And that tunnel is actually tunneled back to my local host. So all I need to do is put in the new tunnel address, which is on a local port 55432. And with that done, I can just plug in some credentials and a certificate that I already have for this machine. And it will tunnel all the way into my host via that worker. And we are now connected to a machine that is living on the private subnet of my AWS VPC and is not exposed to the world, but I'm able to access it without a VPN. And now that I'm here, I can run whatever commands I want. Maybe I just want to check the status of my Vault server. I can spell that right, Vault status. And we can see, everything's healthy, that, the cluster is in good shape. And, once I'm done, I just, I can log out and I can leave. So that's an example of just a very simple SSH connection via Boundary. The next example we're going to show you is actually going to integrate with Vault and pull credentials for us and show us the power of a credential library. So if I try to connect as a DBA to this P-SQL server, not only is it going to establish that tunnel that I need to actually connect to the host, but it's going to also reach out to Vault and it's going to request some time-bound temporary credentials for me to log into this machine and feed them back to me here in the UI. So I don't need to go look these up. They get brought to me right here within the interface. So if I want to go connect to that particular machine, all I need to do is update some information within my connection string. So I'm going to copy these over into a connection string. Give me a second here. Perfect. All right. So once that's done, I can drop them into my console and I can now connect into my P-SQL database. Once again, you can see, we're connecting via, a local host port. We're not connecting to a public IP address. It's a tunnel that's being established from my Boundary client to the end target through the Boundary worker. And, we can run a quick check and see what's inside of my database here. We can log into a different one. Postgres, let me just do an L. So we'll do whatever our DBA tasks are, and when we're done, or when the 5 minutes expire, we can just go ahead and quit, and we can terminate our connection. The Boundary client keeps track of all of our sessions here, And more importantly, all of these sessions are logged within the Boundary controller itself and can be exported to your SIM or other analytics products for further analysis or storage. So we can keep track of all your sessions that are established. That's pretty much it for my demo. Are there any questions about Boundary? All right. On to my friend Greg here.
All right, can you see the screen there?
Yes, we got it.
All right, excellent. Yeah, just orient you real quick. So we talked about provisioning, securing, and accessing. So what we have here is we're just demonstrating that Consul can run absolutely anywhere. And in this case, we're running air quotes on serverless on AWS Fargate ECS, which is a container service. So we have these serverless containers that are running on ECS. And what I want to orient you to is the goal of one of the challenges ATARC gave us, and that was with being able to take generally service A and service B, which is an analyst, and then an agency, and be able to scale this to 1 million containers. And you can reference our 1 million container challenge on that to show how Consul can help you to deliver applications faster and scale up to 1 million with ease. But we don't want to trust anything, right? So we have to ensure that everything is cryptographically verified for this analyst and this agency to be able to communicate. So with Consul, we can do this in one of two ways, or actually several, but the main ways that I'm going to show you today is we can come in here, the intentions, and we can create intentions, and we can do that by source, or we can do that using algorithmic controls or application aware. So in this case, we're going to go ahead and deny the agency to the analyst, make sure we have server client relationship, we will name it. We'll go ahead and deny this application. And then when you come back to our fake service, you're going to be able to see that it's instantly denied. And you can do this in your, your DevOps cycle as you're programming, but we just wanted to show you that your SOC or your control center, you can do this. So this scales, to millions of containers. So I don't want to be too long. I know we only have like 2 minutes left, so I'm going to leave some time for questions. Thank you very much. I'll pass it back to Tim and James. Thank you.
Hey, thank you so much there, Greg. I'm just going to share back my screen and begin to wrap this up. So, what we showed here is essentially a couple of things. Minimal human interaction in building up a pretty large piece of infrastructure, including many, many different components and configuring some pieces of software using Terraform. I showed you a little bit about how you can have Vault dynamically generate credentials for you, what that configuration looks like, and some of the interface of that environment. A very, very good demo by Luke, where he showed us how you can have those employees or contractors, both internally or externally, be able to access with minimal effort resources that are needed for them to perform the normal business processes that are part of achieving the mission. And then finally, Greg was able to show us how you can have that logical network between one service and another service, one application, another application be controlled using intentions. And, for those of you who are wondering, what does it take to build something like this, right? The key message here for you is that you have already got most of those skills in your enterprise, right? So, it took us a number of days to do all of this, a lot of it overlapping, but it's really these 4 things we did. We were doing discovery type work. What do we need to do? How do we design and plan this? How did we build it? And then the presentation piece for what you're seeing today. But if you look at the skill sets required down below, the idea of visioning, being able to time box, being able to manage your time, having some ability to write prose and just write up a presentation, public speaking, having that confidence, ability to coordinate between team members. You have these skills today. And the only two really, the HashiCorp tool specific knowledge or the AWS compute skills, we can teach you those. We or our partners can work together with you to actually bring this into your organizations. And for those of you who might want to try this, right, and go out there, we say, start with a small use case. targeting 3 of those solutions that we just showed you. Go quite broadly, but start small, right? So if you started today, you could easily have a mandate set up so that in a week or week and a half from now, you have a kickoff. You set up your goals and strategies for that particular effort. Honestly, standing up that infrastructure can be done in a matter of 2 or 3 days with some of the learnings that would come with it. You can configure that application access in addition, to what you've done before that with a couple of more days and weeks just with the learning, because it's a pretty new tool. And then really at that point, you have this infrastructure stood up. So we think, in a matter of, for a brand new non-practitioner user or team, you can get something stood up in a matter of a couple of weeks, right? Including your demo and read back to your executives. And so with that, I wanted to move forward into the question and answer portion of this. Are there any questions for anyone on this team that we can answer?
So if folks do have questions, who is the best person for them to reach out to separately?
So if folks have questions, we've actually added all our information here on this particular slide. They can, take screenshots if they like, and we can always make this available so they can reach back out to us.
Excellent. Well, thank you so much. We're at our 1:30 mark. And for anyone online or folks, if you want to share this presentation out, it'll be uploaded onto our YouTube channel. So just go to YouTube and then look up ATARC. And there's a whole playlist for the Zero Trust Lab demonstrations. So you will find it there, and you'll find this one there sometime next week. So thank you, everyone. Really appreciate the time. It's been great. Both presentations were awesome, and looking forward to the next one a week from now.
Thank you, everybody, for your
Thank
time.
you, Kirsten.
Thanks all. Bye. Have a good weekend.